This is a worked example on how to find the sine and cosine of an angle that contains a point not on the unit circle. So just to visualize what we're trying to do here, typically whenever we're analyzing angles, we're working within the unit circle. And so we're working with the circle that is of radius 1, centered at the origin. I know my drawing is not very good, but we have this circle centered at radius 1. And then we're going to analyze points that lie on that circle. And these points are going to look very obscure because they're, again, on a curve between 1 and 1. But then we can ask the question, well, what happens if I have a point that's not on the unit circle and I still want to understand what angle it forms? Well, that's what we're going to be doing right now, essentially. We're going to cover how we can decipher that. So the context for this problem is you want to understand a couple of formulas, and I'll write them down over to the right here. The first thing is that we have that x squared plus y squared equals r squared. So this formula is essentially just the Pythagorean theorem. This is kind of saying that for that radius that I just drew, that's how you can find what the radius is. And then I can rearrange this formula into r equals the square root of x squared plus y squared. And then the other formulas you'll want to know is that the sine function, so sine of theta, is going to be y over r, and that cosine of theta is going to be x over r. And so we're going to use this series of formulas to decipher the angle theta that is formed from this point Q34. So first things first, let's actually figure out what our radius is. So I have 3 squared plus 4 squared, and that equals r squared. And of course, we can use the rearrangement to say that r is the square root of 3 squared plus 4 squared. And 3 squared is 9, and 4 squared is 16. So I get 9 plus 16. And 9 plus 16 will be 25. And the square root of 25 is just 5. So now I know what my r value is. So now I have all three values. And for example, I can say x equals 3, y equals 4. Those are just given from the coordinate pair. And now I know that r equals 5. And so I can use these values to go ahead and solve the rest of the problem. I know from my formulas that sine of theta is y over r, and I can just directly input those in to get 4 over 5. And I know that cosine of theta is x over r, which is 3 over 5. And those are the values of sine theta and cosine theta for a point at 3, 4.